Hello, we are Team 2 of Section 2 for Software Design, and we will be going over our Linter project now. I'm Aaron Fan, and first I'll be covering the three layers part of our design, showing how it models Java classes and how it models the output. After that, I will be talking about the flexibility of supporting a new style check, pattern check, and principal violation check. So here we have an overall quick representation of our three layers design. As you can see, there's a presentation, domain, and data source layer. How it works is we have a presentation which has a CLI handler that Ian Sampson will cover later, which then calls our style checkers, and our style checkers will take the output of the check and move it to an output strategy, which is either a console or file strategy. Now for a slightly more in-depth look at our style checkers, the way it works currently is we have an abstract style checker of which every single type of pattern, style, and principal check extend, and therefore if you wish to add a new one, you can simply create a new subclass of style checker. And what this will do is it makes it so that even in our actual implementation of the logic, there needs to be no changes, since the way we have it working currently is that we have a list of style checkers. And so the only thing that would have to happen is you would have to add a new style checker to that. Up next, I think, is Ian Sampson.
Yeah, so I'm Ian. Right now I'm going to discuss how our CLI handler works. This is like our main interface. It just stands for Command Line Interface Handler. So what you usually do is just run main as per usual, and in main it will run CLI.start, which is our CLI handler. So just, excuse me. Sorry about that. We're going to run main again. I just didn't notice the configuration file was incorrect. Okay, so, one second build. There we go. So how our CLI handler works is you first will open up with welcome to our Java linter, and then you'll select the category for each of the three different checks. I'm just going to run through an example for style check. So I would type 1 if I wanted a style check, and then it would pop up all of our style checks, and that runs through just a loop, so you can add these really easily. Let's just say we want to look at unused variables, so we type in 4. Then it just does what you selected, and then this is the way where we can determine if it's a directory path or a list of class names. Just for this example, I'll show a list of class names. So I would type 2, and then this would prompt you to type out a bunch of list of class names. Just for this example, I'm just going to do one of these checkers just to show that it works. So we can do domain.class name checker. And then if you wanted to do multiple classes, you would just put a space between, but for this instance, I'm just going to show one. So once I run it, you get prompted with if you want to print it to the console or print it to a file. Again, just for this, I'm going to just choose one of them. So I choose console, and it says no duplicated code found, which is ideal because it's just one of our checkers. And then it reruns, and it prompts you again to redo it. And so just for this, I'll just exit to show it off. And it exits and everything works, and that covers points 4 through 8 on the rubric. And now that we kind of covered most of those points, we're going to get into each checker and just give a brief algorithm summary on how those work. So I already talked about unused variable checker. This one, how it works is just loops through all the classes and then all the methods in the classes and checks for any unused variables, and that usually just looks at the opcodes for loading a variable. And one of my other checkers I did was the strategy pattern checker. How this algorithm works is it basically will look to see if you have an interface field first off in the class, and then also see if you have a setter method in the class. And if those are both approved, it looks for if the setter method also takes in the interface and changes it and applies it in a different location. And that's just kind of a brief overview summary. And then my final checker is code duplication checker, which again is kind of like unused variables, where it loops through all the classes and the methods, and it tries to look at the general structures of methods and see if they're pretty similar and or duplicated if they're identical, and then it flags that or not.
All right, I'm Aaron Fan, and I'll be talking about my different checks. The first one I did was class name checker, which was my style checker, and how it works is that it will run through, as you can see, it takes all your class names and it runs through each of them. And the way that class names, the actual strings are formatted, is that the first char after the last backslash or last slash is the name of the class, and from there it simply checks a char2. Char is uppercase. This also supports checking internal classes, which I found are represented by a string after a $sign. So in this case, it's much the same. It checks the first char after a $sign char. My next check was the train wreck or method chaining. How this works, it works much the same way, except this time you take all of your class node, and from there you extract all of the methods. In each method, it will then check the abstract instruction nodes, and if it's a method instruction node, it will add it to a stack. And as you go through this, as you go through the instructions, if the stack size ever grows beyond 2, you should throw a warning that there's a potential train wreck being detected, because there was no proper definition I could find on what a train wreck was, so I simply decided that any method chain longer than 2 has the potential for that and should throw a warning. My last check was the decorator check, in which it is also rather similar to Ian's, in which you would take a directory. In it, you pull out every class node, and in the class, you would check to see if it implements an interface. The next check it does is to check that it takes in the interface in the constructor. So you want to decorate your base essentially. And then finally, it does one last check for a decorated method, which it also forwards.
Okay. I am Lucas Watson, and I will be going over my 3 checks. So the first one I did was the style check, and that was the method length checker. So how this one works, for the user, they can just set how many max instructions they want each method to take, and if it goes over that amount, it will alert that the method is potentially too long. So the first things it does is it intakes the class names, and then it loops over all of the method nodes in the classes. And then for each method, it has some if statements here to avoid things like overcalculating for loops to make sure those instructions aren't counted duplicate amounts of times. For every other instruction though, it adds it to account, and then if a method is greater than whatever you set the max to, it will write to our output strategy. For my principal check, I did the Hollywood principle, which is where superclasses, it's basically we call you, you don't call us. So how this works, we're just checking for each method again in each class. And when we're not in the constructor or init method, we're checking for an instance of a method node. And if that method node equals the superclass name and the opcode is also equal to the invoke special, which is just indicating that we're calling a super method, we would write to our output strategy that that was a violation as well. And then finally, for my pattern check, I did the observer pattern. So how this one works, we first get all the class names, and then for each of the classes, we'll check for an observer list, which is basically looking for the signature observer, meaning that the class implements observers. That would be a giveaway that it is the observer pattern. We also check for the implements observer, and then we check for the observer list to see if you're a subject or an observer. And then for each method node, we loop through the class and the method nodes, and I keep just a list of booleans here that will print at the end to signify if it is the observer pattern. And we're basically just looking for keywords in the methods or key relationships between the methods if they call each other, looking for like if it's an adding observer, if it's a removing observer, if it iterates over a collection, that might use the name observer, just things like that. Those would be giveaways that it might be the observer pattern as well.
Alright, so I'm Ian Sawyer. I'm going to talk about my checks as well. So to begin with the camel case checker, this, it takes in all the classes, it loops over them, and it looks at the fields of the class, it'll look at the method names of the class, and it'll look at the local variable names of all the methods, and it runs them through this regular expression pattern, and if it passes that, it doesn't say anything, and if it doesn't match this pattern, then it'll output to your output method, and it doesn't run that through the constructor of the class, so it won't flag the method name of that, which is just init. And then next is my adapter pattern checker. So for an adapter, it will look through all the classes. It'll check each class for a single field, and if that field is a method of another class, or not method, instantiation of another class, it will check to see if those classes are in the same package, because that would be, if they aren't, it would be indicative of the adapter pattern. It will check to see if it'll look through the methods. It'll see if the method has fewer than 30 lines of Java ASM code, which I decided was roughly about 5 lines of actual Java code. And then it will check if the method has at least one call to the field, one call to a method of the field that is in a different package. And if it passes all those, then it is probably an adapter pattern. And then I had coupling. So for coupling, this has the idea of instability in a system. Instability is the efferent coupling over afferent coupling, and efferent coupling is, I gotta check my definitions here. Efferent coupling is the number of references that a specific class has to other classes, and afferent coupling is the number of references of other classes. Yes, the number of references that other classes have to this class. And so I analyze the classes. I compile a list of all the classes that this class refers to, and I will see for efferent coupling. It will look at the size of that, and for afferent coupling, it'll look through the rest of them, and it will look at it will see if this class's name is contained in that list. And then we calculate the instability with this here, and if this is greater than 0.66, the instability, it will be high coupling, and it will notify the user running the linter.